this. I want to be conscious of people's time. So welcome, everybody. I'm Caitlin Ellis. I'm the Executive Director of Find the Cause Breast Cancer Foundation. I want to acknowledge a few people that have hopped on already. Our board chair, Michael Lindgren. Our Director of Community Outreach, Drew Lindgren. And we've got a few board members that are on here and our event committee members. So delighted to have some old friends and some new friends and people who are very involved in the organization. For those of you who are not familiar with Find the Cause, we're a nonprofit organization solely dedicated to breast cancer prevention, research, and education. And that means stopping cancer before it starts. Like many of the people that are on this webinar, I am going through my own breast cancer journey, and I feel that education and research towards prevention is so valuable, and I am hopeful and know that it is attainable. So I think that this is great for you guys to take a step here and really get some education about something so prevalent in the news today. So I ask that you guys give us a follow on social media so you can stay up to date on some of the things that we're doing. I can't help but plug the fact that we have a big event coming up October 6th, and that staying in touch with us and joining in on that event, you'll hear the update of science from David Shear and the crew that we fund. We fund a consortium of 4 scientists, 2 at Boston University and 2 at Tufts, and really doing some amazing breast cancer prevention research. A few housekeeping tips: this will be recorded and the link will be available to you, so share out. And if we ask everybody to just mute yourselves during this, which would be really helpful so we can get all the information without interruption. Feel free to ask questions. There'll be time afterwards, but if you have some questions during the presentation, throw them into the chat. I'll monitor the questions and try to pull together some like-kind ones. And then Wendy and David have offered to stay a little bit and answer some of the questions. So about our panelists today, who we're delighted to bring to you, Dr. Wendy Heiger-Bernays. Wendy is a clinical professor in the Department of Environmental Health at BU School of Public Health, where she applies her training in molecular toxicology to practical questions about the impact of industrial chemicals, consumer products, and pharmaceuticals in water and waste streams on people's health. Her recent work focuses on the toxicology and health risks of PFAS chemicals. She currently serves as a member of the Massachusetts DEP Waste Site Advisory Committee and the Science Advisory Board for the Toxics Use Reduction Institute, and she's a chair of her local Board of Health. Welcome, Wendy. Thank you for being here. And Dr. David Shear. David is a professor of environmental health and pathology and laboratory medicine. He is currently co-director of the Cancer Interception Group in the BU BMC Cancer Center and is the director of the Find the Cause Breast Cancer Foundation Research Consortium. So we work closely together. Since 1993, Dr. Shear's lab has conducted research on how common environmental pollutants suppress the immune system and induce cancer. This work is focused on molecular signals initiated by the aryl hydrocarbon receptor, a cell protein that famously is activated by a variety of common environmental chemicals. His lab is funded by research grants from the National Institute of Environmental Health Sciences and Find the Cause Breast Cancer Foundation. So this is where the money goes. So I want to turn it over to Wendy and David and thank them profusely and welcome them to this webinar today. So take it away.
All right. Thank you so much for having us here. Can you see my slides in the right mode?
Yep.
Okay, great. So thank you so much for giving us the opportunity to share some of what is known about the per and polyfluoroalkyl substances, or PFAS. So PFAS are human-made chemicals. They don't occur naturally. Their chemical characteristics have improved society, but at a cost. These chemicals make materials water repellent and stain resistant. Great things, but PFAS are persistent, they're mobile, they bioaccumulate, and they're toxic. So I'm going to spend a few moments on these 4 properties because they are the problem. The right side of the slide shows some of the materials that are made with PFAS. Some may surprise you, some may not. How do we know what's made with PFAS? We know because they're measured by academics, by NGO groups, and by community groups. The federal government doesn't require that manufacturers reveal what's in these products. So there's no formal mechanism in place for people like you and me to have known that these things contain PFAS, but we're learning. So persistent, that means they don't break down ever. They don't break down in our water, in our air, in our food, or in our bodies. PFAS contain carbon and fluorine chemicals, and this bond, this carbon-fluorine bond, is very hard to break. It's around forever. It doesn't break down. And it doesn't break down, and that's why these are called the forever chemicals. Mobile means they move. They move from soil to water, from air to soil to water, from water to organisms like fish, and from the environment to us. Bioaccumulative means that they continue to increase in concentration in animals, in fish, in cows, in people. This, coupled with the property of persistence, remember they don't break down, leads us to a place where we continuously increase the amounts of these chemicals in animals and in us. And they're toxic. There's good evidence. Cell models, animal studies, human studies, also called population studies, that these are toxic chemicals. And in fact, studies have shown that many of them are wicked toxic. So how big a problem are PFAS? Well, it's a big problem, but before we all walk away despondent and throw up our hands, this is a problem, but it's solvable using the science and the existing legal frameworks that we have. So let's go back to the beginning. The beginning was highlighted in the movie Dark Waters, if you've seen that. And it focused on this one chemical called PFOA. This is the story of the people who were poisoned by DuPont in Parkersburg, West Virginia. This is where Teflon products were made, where 30,000 people drank this PFOA for about 40 years. That means we have a lot of information and a lot of data about PFOA. There was a lawsuit, and as part of the settlement, something called the C8, there's 8 carbons in this molecule. That panel was formed. There were 3 epidemiologists and a lot of studies that were done. People's blood was measured. We could measure the level of PFOA in the blood, and people were followed for many, many years. And the panel found a strong link between exposure to PFOA and many cancers, colitis, thyroid disease, and elevated cholesterol. To avoid liability, DuPont spun off its Teflon divisions into a new company called Chemours, which is still using PFAS chemicals at the Parkersburg plant. And it highlights the fact that these chemicals are manufactured and they continue to be manufactured. Industry moves much faster than academic scientists who study this stuff, and much faster than regulatory authorities. Our study tools don't allow us to keep up with the industry manufacture of these chemicals. So we have to recognize that all PFAS are persistent, and we need to stop thinking about these PFAS chemicals one at a time. We typically learn about PFOA and PFAS. This has been expanded to a number of other PFAS, but there are about 12,000 PFAS chemicals that are now in manufacture. We also know that a national study called NHANES, that's our national study that follows people over time. We know that 95 to 98% of all people tested have multiple PFAS in their blood. And this means 2 things. One is that we're being exposed to more than PFOA and PFAS. And we also know that communities that have heavily contaminated drinking water have higher levels in their blood than the national average. So on this slide is something that I call the life cycle of forever chemicals. And what it shows is that these chemicals follow those properties. They're mobile and they're persistent. And in the red circle are humans. Well, how are humans exposed? We're exposed in a variety of ways. And the more we study, the more we learn. And it's good to get this information because it allows us to start with where manufacturing occurs, manufacture of PFAS and the use of PFAS in consumer goods and something called firefighting foam. And because of the PFAS mobility, the PFAS moves to the soil, to the water. It gets taken up in food, in plants. And there's a strong interconnection between manufacture, use, disposal, and recycling through the system. But remember, it doesn't break down. So as we make more, as we use more, we add more to the system. And this is reflected in the increasing levels of some PFAS in organisms. Those PFAS that have been banned, we see less accumulation. So let's spend a little bit of time on the water, since this has been such an issue here in the US and globally. Wherever looked, it's found. A new study just came out, which was done by USGS and scientists at Harvard, and they found that about 45% of all drinking waters are contaminated at least a bit with PFAS. So the major contamination source of the water is this firefighting foam, or AFFF. That means that it's fluorinated firefighting foam. Think about airports, fire training facilities, local firehouses, and Department of Defense facilities. And another major source is directly out of the stack where the stuff is used or manufactured. And we can think about facilities such as St. Gobain, for example, in Merrimack, New Hampshire. So what are the major sources or ways that we as people are exposed to this PFAS? So the left part of this slide shows the AFFF and textiles that have been coated with PFAS. Remember, water resistant and stain resistant. So we have the AFFF, the textiles, and I included food packaging here because this is another source of PFAS. We want our food packaging not to leak or ooze, from our grilled cheese sandwich. And so there's PFAS in much of the food packaging, even in the compostable food packaging. These are all containing PFAS, and these substances make, again, materials in water stain and water resistant. In the right side of the slide, I show the water compost, which actually comes from our wastewater treatment plants. When we flush our toilets, we actually excrete some PFAS, and it goes into our sewer system and to our wastewater treatment plants. And in the solids that remain, or the biosolids, we find PFAS. So we have the water, the waste, our waste and industrial waste, and we also have fish, and that we know now that fish contain elevated concentrations of PFAS. And again, it's about this material being mobile from source, from manufacture, through uses, and into waste products. So my point is that they're useful, but they're persistent, mobile, and toxic, and they accumulate over time. So we have some decisions to make. Do we continue to accumulate them, manufacture them as health effects are documented, or do we continue to work to decrease their manufacture? I think Dave wanted this for Caitlin. We know that it isn't just ingestion. We know that there are some behaviors. For example, if you are an active ski waxer, right, and you're doing this as part of your living, you will get you would have gotten inhalation exposure to the PFAS. PFAS are now banned in most ski waxes. So that's a thing of the past. That's good. But the more we investigate, the more we learn. So on this slide, I show a variety of PFAS containing products. On the left, those food wrappers and takeaway containers, including compostables, moving to the water resistant and stain resistant textiles like our couches and our furniture and our carpets, our water resistant jackets and other materials, our dental floss, our paints, cosmetics, pans, and all the way to on the right where we've got medical devices, nanomaterials, semiconductors, right, that all contain small amounts of PFAS. So the question is, can or should PFAS be eliminated if they're not essential, and who decides what's essential? And that's, I think, for us to think about. So is it essential that my sandwich is wrapped in paper that goes to the incinerator where it's burned and the PFAS from it enters the air, deposits on land, into plants and into the water? Perhaps not. Is the PFAS in my medical device essential? Probably. I don't want it to rust. I want it to work. But I suggest that if we're too lenient in our thinking about this, then we'll not actually innovate and make substitutions for these problematic chemicals. I'm going to turn it over to Dave now, who's going to tell us a little bit about some of the health effects.
Yep, thanks, Wendy. So I'm just going to review just a couple of the possible health effects, but the take home is there's a lot of health effects of various PFAS chemicals. And I'm going to start with an area that I'm most familiar with, which is the immune system. And as you all know, your immune system protects you against viruses and fungi and bacteria. And when it doesn't work, you have a problem. It also is the primary defense against cancer. So most people have had cancer in one form or another, fortunately never knew it because the immune system took care of it. And it's very clear that when your immune system is compromised, you increase your chance not only of getting cancer, but increase your chances of the cancer doing really bad things. So I'm going to just very briefly review one particular study here. This was done by a colleague of ours, Philippe Grandjean, where he took children that were, neonates, so just a little bit after birth, and then bled them and looked for just 4 PFASs in the blood. So as Wendy said, there's so many of these, you have to decide which ones you're going to look for. So it's possible we're missing looking at compounds that have real health effects, but these are actually 6 usually that are studied, but these 4 are among the most prevalent and well known. So you measure those 4 PFASs in the blood, then you do the childhood vaccinations, which includes tetanus vaccines, and then you look for the antibody levels at some point thereafter. And what they found down here was that they showed that there was a statistically significant decrease in the amount of tetanus antibody. And that decrease was somewhere around 19 to 29% every time or for each doubling the PFAS exposure. So let's say you had people who had 100 parts per trillion PFAS, and then other kids whose blood contained twice that, 200 parts per trillion. It means that they will have lost somewhere around 20 to 30% of the antibody in response to the titers, in response to the vaccinations. So you can see that as you go up the scale, it compromises the immune system more and more. Here's another example, which you can't, Wendy, on the next one, which you can't really avoid, which is the contribution of PFAS to the immune response to COVID. So this is a study also done by our colleagues where they looked at patients. This is very early on in the process. So this is like in December of 2020. So they didn't have enough patients to really do this in a hugely robust way, but even with a limited number of patients at that time, they found significant differences. So what I'm showing you here at the bottom is the severity of the disease. So they characterize the severity of the disease into a short hospitalization, a longer hospitalization, or people who ended up in the ICU or died. And black is men and gray is women. And what they looked at was for each of these groups, What was the likelihood that they would be able to detect just this one PFAS called PFBA? So in the people who had a short hospitalization, somewhere here, around 28 to 30% of them had detectable levels of just this one PFBA.
Hello?
The people who were hospitalized for a longer period of time, their level was closer to like 35, 36% of those people had detectable PFBA. And the people with the most severe disease, they ended up in the ICU or they died, tended to have, or at least about 50, almost 50% of them had detectable levels of PFBA. And this was a significant increase. So here's an association which helps us make the conclusion that patients with the more COVID severity are more likely to have higher PFBA levels. So it looks like things sort of walk like a duck. Next. There's also metabolic changes. There's a whole field now studying this. In particular, it's been found in both animals and in humans that there is an increase in the total amount of the bad cholesterol, the low density lipoprotein in people who are exposed to PFASs, and that increases as you are exposed to greater and greater levels. It's also been shown that there's a correlation between the increase in exposure and lipids in the liver. That gives you a fatty liver disease called steatosis and signs of liver toxicity. This, as I mentioned, this has been done in animal studies and in human studies, including by our collaborator, Jennifer Schlesinger, in collaboration with Wendy, that have shown some of the mechanisms through which these PFASs can affect both of these particular outcomes, cholesterol and liver toxicity. Next study, next slide. So I'm just summarizing a few of the other outcomes here. Since I study cancer, I included it. Here are just some examples. PFASs have been shown to be associated with increased kidney cancer, so a high exposure to 8 of these PFASs, including P4, it was associated with a 2.5-fold increase in kidney cancer rate. That's a big increase in your likelihood of getting cancer. Testicular cancer was similar, 2.8-fold increase in the risk. Now, breast cancer, which we study within our consortium at Find the Cause, there have been many studies. There was one study that was done in 2020, I think. No, it was an older one in 2013, that 50%, there was a 50% increased risk in all adults if you were exposed to PFASs. People have studied just subsets of individuals, so like young women in particular in Taiwan. They found that there was a 2-fold increased risk of getting cancer if you were exposed to the PFASs. That PFOA exposure was associated with a 7.7-fold increase in a subset of patients that got estrogen receptor negative cancers, which are the more aggressive kind. So this is a pretty big number that basically says that these compounds can make the types of cancers you do get worse. PFOA, and this is now in what's called a meta study. So there have been so many disparate studies all over the place. Some investigators take some of the studies, in this case 8 studies, and sort of average them all in together to see if they give you a pattern. What they showed was that exposure to these 2 PFASs increased the chances of breast cancer in all adult females by 32% for the PFOA and 79% for the PFHXS. So that's a very significant increase in the risk of breast cancer. So the bottom line is exposure to even a limited array of PFASs is associated with higher incidence of several types of cancers. Okay, next slide. Now, just to give you an idea what the potential is, I'll just talk very, very briefly about possible mechanisms. And the reason I do this, and the reason we study the mechanisms, is because if you see a chemical affect a particular mechanism within a cell that's critical for all kinds of normal biologic functions, development, wound healing, basically everything a body can do. If you see those mechanisms altered by the exposure to these chemicals, then the potential is the outcome is going to be a lot of aberrant biologic responses. So at the moment, scientists have found basically 2 plausible mechanisms through which these chemicals can do bad things. And the first one is that it changes the DNA in a way that changes what genes get expressed. So all of us have somewhere in the neighborhood of 20,000 genes. And the different parts of your bodies will use some of those genes at one point or another to become a cell that makes a skin cell or a lung cell or whatever else, any other kind of cell, and to make it function properly. These PFASs go in and change the programming in the sense that changes which of the genes get expressed. And that's not the kind of thing you want to do in a cell that's participating in a critical biological function. And the second mechanism through this works is that many of these chemicals interact with receptors within cells. And these receptors are there so that various parts of the body can talk to other parts of the body with things like hormones and small molecules to tell other types of cells, this is what you should be doing right now. But it turns out that many of the chemicals will activate these receptors in an unpredictable way. And maybe one of the examples that would be easiest to understand is the estrogen receptor. So I'm sure many of you know that hyperactivation of the estrogen receptor is a contributor to breast cancer. And what has been found is that several of these chemicals actually can activate the estrogen receptor, and exposures associated with the cancer that then becomes much more aggressive. Again, the estrogen receptor negative types of cancers. So the point of this slide is just to show you that very basic mechanisms of cell biology are messed up by exposure to even small concentrations of the PFAS. So on the next slide, Wendy, you can show them, just a summary of all the places that seem to be impacted by exposure to PFASs.
Right. So Dave explained 3 of the best studied health effects that we see in humans in epidemiologic studies. And so PFAS is here. There are effects that are observed in the population, and these effects are happening at very low exposures and very low concentrations. This slide is simply showing you that this is a class of chemicals that affects multiple systems. And this is unlike any of the other chemicals that Dave studies or anyone else studies, because these chemicals are really, really interesting in that they're able to get into almost into our cells and do damage, some of which Dave explained. And so this is really costly to people's well-being and to our society, right? So what can we do about it? How can we limit or decrease our exposure? How do we stop this train? So we have 2 tools in public health. We have education and we have law. That's what we got. So in the United States, there is no federal drinking water standard. And there are just guidelines for 2 of the PFAS, the ones we've been focused on, PFOA and PFAS, because those have been studied for the longest period of time. A couple of months ago, EPA proposed drinking water standards for 6 of the PFAS listed here. And we'll see if these standards are actually promulgated. Promulgated means that they are turned into standards. They're passed into standards. The difference between a guideline and a standard, one is legally enforceable. That's a standard. The guideline, that's simply a suggestion. And the feds can say, well, you really should meet these levels. Okay, so 5 years ago in Massachusetts, the Department of Environmental Protection promulgated drinking water standards for 6 of the PFAS. That's called now the PFAS 6 that many of you are familiar with. And these standards were derived with the intention of protecting the developing fetus. And the thinking is that if you protect the developing fetus, where the doses required for the effects are much lower than for many of the other effects, that you would also be protecting adults and other stages of life. So if you're interested in to learn which communities have or had elevated PFAS, there's a link I can share with the group. The point is that there were two components to the law in Massachusetts. Actually, there were three. One is the standard based on a sum of 6 PFAS. Two was that the state would take a look and revisit those standards after 5 years to determine whether the standards were sufficient. Are they health protective enough? And that is being revisited in this late August and September. And if EPA actually comes out with a standard, the state cannot have standards that are less restrictive, but the state can have standards that are more restrictive, more health protective. And we will be watching this and see how that goes. So those are the regulations for water, because water is a critical exposure medium. We have regulations. In fact, EPA has all the tools it needs in the Toxic Substances Control Act, or TSCA, to regulate these chemicals as a class and not one by one. And why don't they do it? It's simply money and power. States can regulate. Massachusetts has. We've regulated PFAS in drinking water. There's the bill that is moving its way. Actually, it's just about law, which is called the Mass PFAS Act, that should be voted on. It does ban PFAS as a class and has certain exemptions. Now, there are also local ways to address and to limit the use of some of these compounds. Boards of health, for example, in your municipality, have the authority to do this. You could require or not require changes in how you do business. So effective advocacy is informed by the good science. So what can you do? So consumer choice, knowledge is power. Test your water. Have your water tested. Make sure that you understand what those concentrations are. If you're in a municipal system, you can rely on the municipal data. These are not added in the pipes that are leading to your home. They're coming from the drinking water source, most likely from a groundwater source. Watch your diet. Increase your consumption of fruits and vegetables where we know that the concentrations of PFAS are lower, and we know that we can that consuming fruits and vegetables can also affect how things move through the gut. And that's good. Less meat. Limit locally caught fish. If you're interested in knowing where there is now a strong statement not to consume fish from local water bodies, that information is available. Read labels. PFAS free does not mean no PFAS. PFAS free typically means no PFOA or no PFAS. It does not mean no PFAS. So what you want to see is no fluorochemicals. And use compost in your gardens that state no biosolids or wastewater products are used to make up this compost. So you can also work in your communities, in your municipalities. You can work on purchasing and resource allocation. Remove sources of PFAS to the environment. For example, many communities are rethinking artificial turf because that artificial turf contains PFAS. It's not a problem for human exposure directly. It is a problem because it discharges the PFAS into the environment. And now you know that once it's in the environment, it's going to circle around and become part of us. Municipalities are changing what their schools are using and requesting and requiring different packaging materials, for example. And industries and businesses, these practices, in your world, switching to fluoro-free products is a way to take action to decrease the levels in the environment and in us. And of course, there's always the law route, the contact your Congress people, but sometimes that seems to be a little daunting. And so I'll stop there. I want to thank Find the Cause for sponsoring this and for allowing us to share some of what we've learned. And I'm hopeful that you've learned a little bit more about PFAS. So thank you.
Wendy and Dave, that was fantastic. I learned even more than I knew before, and I think I always walk away with a nugget or two. If you have a minute, I know that there's some questions out there. One was talking about a reverse osmosis filter for drinking water in your house, and is that helpful?
Yes, it is absolutely very helpful. You've got to make sure, though, you maintain the system. You've got to make sure that the person or the business that is maintaining your system is coming in to change out the filters. If it's you that's doing it, make sure that you change out those filters. The reverse osmosis is probably the best system. It's expensive, but it works, and it will capture even some of the small PFAS, the C3s, for example, 3 carbons that some of the other systems won't capture.
Great, thank you. Other questions? I'll open the floor now. I was reading out of the chat.
Yeah, maybe Wendy, you want to address some of the questions I started to answer, but since you're the expert, one was, is there a particular kind of fish that is safer than another?
Oh, this is, yeah. So in locally caught fish, there is evidence that all of the locally caught fish, regardless of the type of fish, contains elevated concentrations, mostly of PFHXS, telling us that it probably comes from firefighting foam. That's probably where the PFAS comes from. If you're consuming bought fish or fish from elsewhere, we have very little data available right now on marine fish and on farmed fish. Those data will be coming out, I'm virtually certain. Always lower on the food chain is a better bet. So if you like sardines, go for them. If you like anchovies, go for them. Best not to go all the way up to the tuna, right? Because that will have concentrated the PFAS. They live longer, they're more exposed, just like us. So yeah, you want to go lower on the food chain.
Wendy, thank you so much. And David, it was so informative. A couple of questions, it's kind of a multi-question, but how long have PFAS been around? How long have we known about them? And how much have we, sorry about that. And how much have we, over the last couple of years, made progress to eliminate them? So are we going in the right direction?
We're going in the right direction, but we're not going fast enough. We are not going fast enough as industry continues to substitute. We call these, these substitutions, these substitutions result often in something that's more toxic. So let me go back to your original question. Late 1930s is when PFOA was introduced. That's a long time ago. My grandma, right? So 1930s, 1940s, and then all the way, we started increasing our use of PFOA, right? All the way through time. We got all these great products, and our lives were made a lot easier because of non-stick this and non-stick that. And then what happened was there was evidence that PFOA was toxic. And so there was a substitution. It was a regrettable substitution. We went from PFOA to PFAS. The only difference is we changed out a carbon we actually changed out an oxygen for a sulfur group, and it was thought that that would be less toxic. It's actually more toxic. So one, PFOA, PFAS. We don't use PFOA in the United States anymore. It wasn't banned, but but industry stopped using it. It was substituted with PFAS. Industry is still using PFAS, but has moved on to other regrettable substitutions like Gen X, for example, right? Which is Chemours that started out as DuPont and is now in North Carolina. China still manufacturing PFAS, still using it. When we import stuff into the United States, either as raw materials for manufacturing, or we import materials and we purchase them, we still find PFAS. So it's not gone. And then we got the PFHXS substitution. Instead of being 8 carbons, is now 6 carbons. So it was thought, well, if you make the chain shorter, it'll be less toxic. No, it isn't. And in fact, because the chain is shorter, you actually need more of the stuff. So, so that answers one part of your question. The other is, have we learned a lot? Yes, we have learned a lot. I would say in the past 15 years, we have learned an enormous amount. We have colleagues who were working on that original study, right? And that was 15 years ago. And they showed, actually, we had a graduate student who showed that cholesterol was associated with PFAS. And since that time, research has expanded, it has blossomed, right? But the problem is the amount of money that is spent on it is still a drop in the bucket. We have the tools. We should be using the tools that we have, the laws that we have to require industry to say, stop. We're not going to use this any longer, except for certain reasons. And for those reasons, you've got to justify what those reasons are.
This is a big question, but why not say stop? What is it so expensive to create a standard instead of a guideline?
For water?
For water.
For water, no. I mean, we're going to end up with a standard, but the problem is going to be for which PFAS.
Yeah.
And the point is, we got to do them all. Right? We got to do them all. We got to say, stop looking at one at a time, because neither you nor I are going to be alive. Even by the time we look at 10 of them, we barely have information about 6. So we've got to take a slightly different view and say enough of the chlorine fluorine bond. And I think there are reasons for the essential things. I think there are reasons to suggest that we might want to keep them, but that we want to encourage substitution with a totally different chemistry. And we want to do that both in a thoughtful way and with a hammer, like do it now.
Yeah.
Wendy, I have a quick comment and question, because it does, we do, we need to eliminate them. And that's an eventuality, right? Hopefully that we do reduce the amount that we're putting into the environment. The other side of it is how much effort is being made to come up with alternatives. Because
Very little, because there's no incentive. That's the problem. The incentive comes from a hammer, right? The incentive comes from, on this date, you will stop using fluorine for these processes. The European Union, OECD, was about to do that, and they've backed off. So I don't have a great answer. We just have to keep plugging along and encouraging our legislators and empowering EPA, because again, they have the tools to do it. But the lobbyists are really powerful, of course, right?
Yeah, and I do understand that. I actually do know that there are alternatives, oddly enough, and it's these are new burgeoning companies. But I wonder, is this a role for academia? Come up with an alternative. I mean,
Oh, so you're asking about the chemistry for alternatives?
Yeah,
in
you
the
know,
academic- So the answer to that is there's not a lot of money being put into that at all for research for that, right?
Well,
And so
like
unfortunately.
find the cause.
Well, that's not even, it's problematic. There's
Yeah.
not enough. Most of the budget actually is held for PFAS is actually held by DOD. It is not even held by NIH. That's a drop in the bucket. And DOD is really nervous, right? Because they've contaminated how many drinking water supplies.
Yeah.
And there's this latest lawsuit, right? The settlement of what, $2 billion or something like that, to go to all these municipalities to filter their drinking water. It's not even going to cover Massachusetts. It's insufficient.
Yeah.
And they got off because, well, the lawsuit, removed them of liability.
Wendy, I think we have a couple in the chat. Pamela, I don't know if you want to ask your question or you want me to read your question. I see you're there. Why don't you ask?
Yeah, sure. Thanks. I was wondering if you could talk a little bit about, does PFAS pass through the body? So once you bioaccumulate it, does it kind of reach some kind of max capacity, or is there anything, I know not necessarily medicines, but things you take or, anything that helps you actually pass PFAS through your body so the toxins don't stay in your body longer? And what studies have been done around that?
Yeah, a couple of points on that. That is the holy grail. Right. PFAS, especially the longer ones, have half-lives of years in the body, right? And so they are not metabolized. They are excreted, but very slowly. So one of the things we would want to know is how can we excrete them more quickly? They're generally excreted, some mostly urine, some in feces. Right? But very slowly, we're talking years. And if we are continuing to put them into our bodies, we have to recognize that we have two sources now. We have the stuff that's coming in and we have the amount that's going out. Those rates are not equal. The amount coming in is significantly larger than the amount going out. Right? So in some cases, there is a suggestion that, if you were to increase, for example, your gastrointestinal activity, could you increase the rate of elimination through fecal excretion, right? There's research, actually, we're working on that. There's research on that now, but there is no magic bullet. The only way to do it is literally bloodletting. Okay, so people who have had transfusions, people who have had large amounts of blood removed, end up with lower concentrations of PFAS in their blood. And I don't think that is a reliable mechanism.
No, certainly not. Thank you.
And breastfeeding does remove some, but then you've exposed
You've
the
put it to
the
child,
infant.
right?
Yeah.
And maybe just one other comment, since you mentioned filtration. The challenge with the PFAS going on granular activated carbon, which is usually where it goes for filtration, is then it moves to a landfill.
It
and
does.
then it's PFAS laden, and as water goes over that,
Yes.
that contaminates someone else's drinking water. And then
Yes.
it perpetuates the cycle, and that gets moved to another location. And usually it's environmental justice areas or shipped to other countries or other places and just moved around and perpetuates.
Yeah.
the cycle. So it's
You're
really,
you're absolutely correct. And I think that some of the research now is going into, are there ways to break it down? Are there, there's some evidence that really, really high heat might be able to break it down, but you're still left with the carbon fluorine, right? And there is some evidence that some types of incineration with adequate capture on the stack is probably better than the landfilling, because landfilling is not forever. As you point out.
yeah,
So
the gases off of incineration there's issues there as well. So, yeah.
I don't know. Should I take some of these questions?
We have one from Gail that says, how can we identify the items that have PFAS, for example, in our furniture, wrappers, household items? Is there a
So
way to-
you are going to need to assume that they are in there. That is the safest thing to do. If you are purchasing new couches and textiles, they will be very clear. We don't use fluorine in our, in our processing. On the other hand, does throwing everything out help the situation? Probably not, because then what you're doing is you're putting it back in the landfill and it's coming back. Is the couch behind me a problem for my exposure? It isn't I wouldn't say it's one of the major sources to me, or if I have small children here, it's to recognize that it's in there, right? That there is dust that can be, on the ground that contains some of the PFAS that came from the textiles. So it really goes back to the way we think about purchasing and, less is more, judicious in our purchasing. Do we need to purchase, however many, clothing items where some of them contain PFAS? The answer is probably not. There are occupations, firefighters, for example, who have, their uniforms are in these turnout gears are embedded with PFAS, right? And so, they have an exposure that is much higher than ours. And that exposure is real, significant, measurable, and their illnesses are likely associated with their turnout gear. Is my couch my problem? No. My drinking water, the fish that I consume, right? That is where my exposure occurs. But the products that I use are going to go back into the environment and ultimately expose others and myself, perhaps.
So Wendy, a couple more that are in the chat. Jeannie asked she said, I was told that fluorine was good from some dentists.
So that's fluoride. Fluoride and the fluorine that we're talking about are two different beasts.
Right.
They're not connected. So fluoride for another day, that's a whole nother story. So Jeannie, in terms of your dentist, they're not talking PFAS, they're talking fluoride for cavities.
Great. And then Sue asks, does this carbon fluorine bond occur naturally?
No, it does not. It does not. There is a little bit of evidence, hasn't been repeated, but essentially the carbon fluorine bond is not found in nature.
Yeah.
And it's
So-
probably not found in nature because it doesn't break down.
Certainly not in long chains like this.
No. What else?
Anything else from the audience? I covered the chats. Unless you were direct chatted.
I know we know ingredients for food, cosmetics, and personal hygiene products, but other products, utensils don't require yeah, we don't require labeling. Now, Maine just passed a law that is extremely prohibitive in terms of purchase of materials, that literally purchase of and import of materials into Maine and for sale as well that contain PFAS. And their definition of PFAS is it's called a fully fluorinated carbon. It means that they have literally one fluorine on a carbon. So they're looking at literally everything. It's going to be challenging. I mean, I actually think we could do this if we did it regionally. I mean, if you had a whole New England states, right, take an approach, you could actually do some purchasing and, facilitate this like we did with mercury, but doing it state by state, I don't know.
So Gail asked a good question. What's the solution for disposing of items that will likely contain PFAS?
Right now, the solution, we don't have a solution. Right now, most of our stuff is going to most of our stuff is incinerated, right? Because we don't have any more landfill space. So, we are putting it into incinerators, and we're burning it. And as I think it was Pamela pointed out, that it goes elsewhere and other people are exposed. So yeah, that's what we got. I think it's going to take turning off the faucet.
And Margie made a comment that Mindful Materials database addresses PFAS in building materials, which I think
Yes, that's great. There are a number of resources that are really good that you can use to identify, where there is PFAS. And we can give you some of those websites. Some of
Yeah,
them
she just
are
popped
really,
the
really
link in the
good.
chat, but if, other resources for sure,
Yeah.
would love to put them on the Find the Cause page, because we have a resource page there, and get people driving traffic to visit us at Find the Cause.
Yeah, and I do think, know what's in your water. If you have a private well, the state isn't responsible for you. The law isn't written that way. If you have a private well, it's good to know. I know that there are liability issues, but it's good to know. And actually, Environmental Working Group just posted a link to some of the at-home filtration systems, the pitcher filtration systems, the newer ones. Brita is not going to help you. So don't waste your money there. Is bottled water safer? It depends where your bottled water comes from. And in fact, in Massachusetts, when a community has elevated PFAS, the state tests the bottled water that's being provided to make sure that they're not giving people more PFAS from another source. So unless your bottled water is documented, don't use the bottled water, because the bottled water contains the plastic, and the plastic is a whole nother issue that is actually connected to the PFAS problem. So the less plastic, rely on your municipal water supply, do your due diligence, use your new pitcher if you're able, and knowledge is power.
Well, thank you very much.
I just make one quick comment about WG. We're not advocacy, but EWG is their great resource. But I just responded to an email where they made it very easy for me to write to my state senators
Right.
and representatives about PFAS. So
I think the only thing I want to leave you with is that with all of these bills and laws, there is nothing that is telling, there's no money allocated for DEP to actually do that work. So you have to have the law, but in there you have to have money from the legislature to increase the capacity for the agency to do that work, to enforce. Without enforcement, you're back to a guideline. So that's another piece.
Great point. Well, I want to be respectful of your time, Wendy and David, and it's 1 o'clock, and we appreciate the hour that you've given us. I'm sure, I know, speaking for myself, I could talk about this all day and be learning all day. So I thank you so much for everybody who joined us today. Follow-up questions, happy to field them to Find the Cause, Caitlin at findthecausebcf.org, and I can pass them along or into our info box there. But certainly reach out. This is a long topic, and I'm sure it will be an evolving topic. So I'd like to just put a little seed out there that would love to revisit this topic with our experts as this progresses. So thank you so much for being with us and giving us your time today.
Thank you for having us. It's really fun, and we can do something.
That's hopeful.
Thanks,
Perfect.
David. Thanks, Wendy.
Thank you all. See you later.
thank you
Have a
all.
great day, everyone.
Bye. I guess Dave's gone.